Hello and welcome to another video. Today we're going to be working on reverse linked list 2, which is similar to reverse linked list 1, but now we are reversing a chunk of a linked list, not the whole thing. So for example, given a linked list of 5 elements and given 2 and 4, we need to reverse the linked list from nodes 2 to 4, and it's 1 indexed here. So this is 1, 2, 3, 4, 5. So, and yeah, once you do that, then you would reverse it. So how do we do this? So let's actually go over this problem exactly. So we have 1, 2, 3, 4, 5. And what we're going to do as always, or as in most of my problems, we're going to create a dummy node because we are going to reverse some chunk, so then we can refer to that part that we reversed. So we're going to create a dummy node. It's going to point to the head. And we can index these, essentially. So this is like 0, or actually be more like 1, 2, 3, 4, 5. So essentially our goal is to get, like if you think about it, this is the section we need to reverse, and we can actually color it a bit. So the section we need to reverse is 2, 3, 4. So in order to reverse 2, 3, 4, like that part is pretty straightforward, but we need to get the nodes before and after them, so then we can do the connections at the end. So essentially, we would have to start, like, what we're going to do is we're going to have a cur and a previous. And essentially, we want our cur to be here for the first iteration and the previous to be here. So how often, like how far would that need to go? It would need to go the left amount, right? So the cur is going to start here, and the previous is going to start here. And we need the cur to be at the node that we want to be reversing, and the previous needs to be right before that. So we would just say, like, okay, let's just move it up L amount of times. Now, once you get here, now we can say, okay, well, we want to break this. So we can say like previous.next is none, and we want to actually store this variable. So we can just store like a left, meaning the left side of the result equals that previous node. And here we also want to store this as the node that, like, we want this part of the list to be reversed. So we can just say like head or something, whatever value you want to use, equals the current node. So that's the first part. Now what you want to do is you want to do the same thing, but you want the current to be here and the previous to be here, so you can once again break this thing. And so the way to do that is honestly also pretty straightforward. And you can just do it, and you don't need to use 2 nodes. You can just use a current if you don't want a previous, but I'm just going to use a current and a previous. So essentially what you would do there is you would say like, okay, how much more does it need to go? So I was at left. So if I go 2 more, I'll be at right. So I need to go right plus 1 here. So I'm going to go right plus 1, so I'm going to go 3 more nodes, and now my current and my previous want to end up here. So previous, current, and now same thing. I want to store this value. We can call that like maybe the right or something, right? Equals current, and we want to break this thing wherever the previous is. We want to break that. So now we have like a before list, an after list, and then the part we want to reverse, right? So now to reverse a linked list, it's pretty straightforward, right? You have a current node and a previous, and you just make a temporary node. So if we have like 2, 3, 4, and we want to reverse this, you have a current node and you have a previous, and normally your previous is none, but we want, notice in our result, we want our first node to actually point to the end. So we're actually going to set our previous equal to this last node over here. So previous will be 5 here. So 5. And essentially, it's pretty straightforward to reverse the list. Now, you just make a temporary node. That's going to be the next pointer of the current node. Then you make current point to previous. So we'll get rid of this. Then you make previous equal to current. So we'll move that over here. And then we move current up to be that temporary node. So now current is over here. And we do the same thing. So we make a temporary node. That's the one after current. And we say current point to previous, and then previous equals current, and current equals temp, and this temp is gone, and same thing again. So the previous is now here, and you say, okay, temp is cur.next is over here, current points to previous, so we will do that, and previous equals current. Previous is here, and then finally current's out of bounds. And now we are done because our current's out of bounds. So now we have this linked list where we have our reverse list, and it points to whatever was over here. So now simply what we need is to connect the part before the list to that. So previous is going to be the head of our new list. So then we just say left dot next equals this previous thing over here, right? And so left is 1. So then you will have dummy node 1, 5, 4, 3, 2. Actually, you don't want left.next to be the previous node. You want left.next to be... No, actually, you do. Never mind. Yeah, you do. So you want left.next to be the previous because previous will be over here. And this will point to the 5 because we assigned originally our previous to be that right node. And then that's pretty much it. So once you have this whole list, then you just simply return dummy.next, which is the first node in your linked list. So we can write our steps here just to make it clear. So make dummy node. Then traverse to left pointer, wherever that is, with a current and a previous. Then set left equals to current and previous.next to none to break that. Then traverse to right pointer. And we can actually do this, add a little more space. So we traverse to the right pointer, and then we do the same thing. We set previous.next equals to none, and we set previous to be that right node. Right node. And then we reverse the middle list section, and finally connect left to the head and return dummy.next. Now you can simplify this, but this is like kind of the way you do it. So, brief overview once again, you simply make the breaks before and after your list. You save those variables, the variable before and the variable after. You set previous equal to that when you do the reverse, so that way the head of the original list points to that, as it should in this example, as you can see, right? So the head of the original list needs to point to over here, which it does. And then you reverse the list, and then you make your left point to that reverse list, and finally you return dummy.next, which points to the head of your overall list. Okay? And yeah, like all other problems, this problem is just using pointers, figuring out what you actually need to do, where you actually need to be. You can probably save some variables by not using a previous at a certain point, but it helps to have 2 pointers, so that's what I'm going to do. And now we can code it up. So we are going to make a dummy node. And it's going to point to the head. The value is 0. We don't really care about the value. Then we're going to have a current and a previous, as I said. Then we are going to say the index is 0 because the dummy node index will be 0, and this is like 1, 2, 3, 4, 5, and so on. So we can just say while index is less than left. Let's just keep going forward. So previous equals cur, and cur equals cur.next, and index plus 1. You could also do this in a for loop if you wanted to. Totally fine. So now our previous is the node right before this the first node we're reversing, and the current is the first node we are reversing. So we need to save those values, so we can just say left equals previous, which is the node before we're reversing. Then left.next equals none. We want to make a break here, right? This part we want to break. And we're going to make the head equal to cur just because we already have a head. So head will be the head of the list we are reversing. Then we need to keep going to get the right side of that. So while index is less than right plus 1, let's do the same thing. Previous equals cur. And you can combine these while loops if you wanted to and have just a few more checks, but it's like 3 lines of code, so not a big deal. And like I said, you could also do this in the for loop. Okay, so now our current is over here, and our previous, once again, is the end of the list. So what do we want to do? We want to set the right equal to cur. We want to say previous. Actually, we don't even need a right, technically. So yeah, we don't even need a right. We can just say previous.next equals none. And then we can just say previous equals cur, because we want previous to start here. That way, when we make our node node.next equal to previous, this 2.next will point to 5 right away. So we could say previous next equals none, and we can just use previous equals cur and not even need a right. So we save a node there, and then we do our list reverse. So remember, previous is going to start with 5, and current's going to start at 2, and we need to keep doing it until cur is out of bounds. And cur is the head in this case. So while head temp equals head.next, head.next equals previous, previous equals head, and head equals temp. So that will reverse the list. And finally, now that we did that, so that reversed our list, and it also made this 2 point to the 5, but now we need our left side to point to the start of the newly created list, so we can just say left.next equals previous, which previous should be the head of our new list, and now we finally return dummy.next, which is the head of our completely new list. Let's test it out. And hopefully we don't have an error, but it looks like we might have an infinite loop. I think so. Probably forgot some index or something, but we'll see. Yeah, temp exceeded. Okay. So let's go through our code. So dummy equals this. This part is fine. While index is less than left, previous is cur. That's fine. Left equals previous. Next. This is fine. This is fine. So here we need to just double check. Previous.next equals none. Previous equals cur is fine. Then while head temp equals head.next, head.next equals previous. Yeah, so our error is we wrote head p instead of head, so we never updated our head. Okay. And as you can see, it's reasonably efficient. You can obviously clean this up, put it into a few loops, maybe use one more variable, but it's still going to be the same time and space. So let's think of the time and space here. And yeah, this is kind of like, you can also make a helper function to do a reverse, but because you're only doing a reverse once, it's also not great. Because if you are reversing, like let's say this was reverse k nodes or something in a list where you're doing multiple reversals, then a helper function makes sense. But because you're only doing it once, no need. So essentially, for the time, we are going through our list, and we do reverse one chunk. So that one chunk reversal will take, worst case n. So this would be roughly like 2n, which simplifies to n. And for the space, we didn't create any new nodes. We just simply changed pointers in place, and we have a couple pointers, but it's only 2 or 3. So that's O of 1 space. And yeah, I think that's going to be it for this problem. So hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.